Hello and welcome to the channel, and today we're going to be looking at this bad boy. Now this is an Si5351 Breakout board that I've developed. So you're probably saying to yourself, hang on a minute, we've already got Si5351 Breakout boards. Yes, we certainly have. So there's a few limitations to these things. So what I have attempted to do is to address some of those limitations. Now, for those who are not familiar with these boards, this is basically a clock generator. You have to control them with the microcontroller via I2C. But what they do, they will create three separate waveforms at separate frequencies. And through the programming, you can set them to whatever you like. As long as it's within the range. I think it's 8 kilohertz through to about 200 megahertz. Now, there's a few caveats to that, but we'll look at that as we go on through the video. So, one of the things that these units get used for, and it's quite popular, is for modifying radio equipment. And what happens is, by installing one of these, you can actually improve the performance of radio transceivers, and it's to do with the range and tuning. Now, by doing this, a lot of the time, a lot of radios have FM frequency modulation, and by the fact of disconnecting the main synthesizer within the radio equipment, what you're doing is taking away the facility to modulate FM, because of course it's done by pulling the VCO. So what I've done, I've added FM to this, so we can actually modulate FM on a local oscillator. So, which is quite useful. And there's another thing as well, which I've put into this, which is I've used a temperature-controlled oscillator. Now that's for the reference. Now these run at 25 megahertz. They will run at 27 according to the data sheet, but I've certainly had no experience with that, so everything's set at 25 as per. This is very similar to the design here, but you know, on the traditional boards, these use a crystal. They're very sensitive to temperature, and the further you get away from the reference frequency, which in this case is 25 megs, you know, the instabilities that you've got are, you know, they're basically amplified, you know, for want of a better word. So they can become a little bit unstable, and this seems to have improved the situation using a temperature controlled oscillator, or TXCO. Now this has got a stability of 2 parts per million, as opposed to these, which I'm not quite sure, but you know, it's noticeably a lot more stable. Incidentally, this has the same form factor as an ordinary breakout board. The pinouts are exactly the same. Yeah, you could actually just drop this straight into an existing project with your existing code, and it will work straight off the bat. With the advantage of having a stable clock frequency. You wouldn't be able to modulate FM. You know, we've got to manipulate that in the code, but yeah, this is exactly the same. So you just literally drop the unit into an existing project if you so wish. So in this video, what we're going to do, we're going to basically, you know, show you in action, just a brief overview. You can see the thing working. Then we'll have a look at the schematic in some detail, how I've developed it. I have quite a few issues, you know, hurdles I had to sort out. But yeah, we got through it and it works reasonably well. I'm quite happy with it. We'll also look at the code, what you need to do to code and make this thing work if you want to do FM modulation. And you know, we'll just how to get the best out of it, and in the end we'll put it into a sort of live working environment, and you know, possibly do some performance testing. Okay, apologies, it all looks a little bit Heath Robinson. So let me explain what's happening here, and we'll try and test the FM modulation. So what we've got here is a board. This is a VFO board. This is something I've developed. It's called the Band Surfer. There's a lot of videos on this, so I'm not really going to go into it. However, it's a controller. It's got an ESP32 on there. And we've got our new Si5351 Breakout board connected to it. So as you can see, we've got a display, and we can change channels if we so wish by this rotary controller here. So what's happening is we've got this radio over here. Well, you can see that. Now, what this is just an old Cybernet radio. It's got FM facilities, but we don't really need that. I'm only using this as an audio amplifier. So if I set this to FM, and what's happening is this unit is controlling the band surfer. So these are just sensing cables that are going into this socket here. It's just so that the unit knows which mode we're in. Now it needs to think that it's in FM. Well, it is, because I've set it on the channel on the mode selector here. So what is happening is I'm taking the audio. This is nothing special. This is just the audio path from this old Cybernet, and it's plugged into the header on the Si5351. So if I now key up, obviously it will know, it'll go into transmit. You can see the unit goes into transmit. The radio's not doing anything. We're just looking at this, and we're just looking at the output of this clock generator, which is going up to a test set, which we'll look at in a second. So what I need to do is just quickly configure this. So if I get it into menu mode, I can go down. We go to the clock gen menu. Okay, so it's telling us we've got a type A install, so we can hit the button there and we say no. We've now got a type B because we've got a type B clock generator on there. We'll go through this in the schematic. We've got FM enabled, FM mod enabled, and we can now adjust here the deviation level. So let's say 2.5. Now, obviously, this unit is connected up to a test set. It's got a crappy speaker on it, but if we key up, 1, 2, testing 1, 2, I don't know if you can hear that. Okay, so as you can see, the frequency is 27.205. It's because I've not got an IF offset set, so that's exactly what's being displayed. And if we key up, you can see the FM deviations going up. Now this isn't very scientific, I know, but we can do some much better tests, and we'll do that at the end of the video. Okay, so we set up now, as I said before, we haven't got any IF offset on this, so the frequency we're generating from the clock generator is the frequency is displayed on the LCD. So what we're doing is the output of this is going into the back of this multi-mode 11 meter receiver, and if we can change temp, you see it's very strong. We're looking 0 dBm, so there's some adjacent channel noise, but that's basically it. So it's feeding in there, and as you can see, it's full stopping the meter on there. So if we speak into the mic, obviously we've got the same setup as before. Testing 1 2 1 2 3 1 2 3. Now it's probably a bit hard. I've got the little lapel mic. You probably can only hear my voice, so I'll put that under here. Okay, you can get an idea of what it sounds like.
Testing 1 2 1 2 3 1 2 3. There is a little bit of feedback there. I can back that off a bit. 1 2 3 1 2 3.
And of course we are set to FM, and if we look on here, what we can do, we can just put this into menu mode, advanced settings, clock gen menu. And you can see we've got a type B installed. We went through this before, and we can see our deviation. Now
the deviation is actually adjusted by the microcontroller, so I can adjust this now. So if I take it down 1 2 3 1 2 3 1 2 3 1 2 3, you can see the deviation has come down, and I can take it down as low as 500 hertz, half a kilohertz. So yeah, 1 2 3 1 2 3, and as I'm increasing it, you can see that 1 2 1 2 1 2 1 2. Now we're getting to the point where this is too wide for the radio.
We've changed channel. So we'll set that at say 2. I have to come back out to change the channel. Yeah. That's a little bug in the software I've got to sort out, but to menu.
1 2 1 2 3.
Yes.
So if you didn't want the FM on here on this unit, you can literally switch it off. So I can go FM mod enabled,
FM mod disabled, so it doesn't do it and nothing comes through. So yeah, you can hear it. It sounds quite good. Now there's a few things here. I'll put the lapel mic back on. There's a few things to pay attention with here. Now this mic audio that's coming in here, the audio, this is why I've used the radio, because the audio path in these units, the mic path goes through some amplification, but ultimately, I don't know whereabouts it is on the board, I think it's over here, it goes through the audio power amplifier. Now the reason they do this is to up the size of the amplitude of the waveform. So the signal coming in at this point is a couple of volts peak. Now it's obviously single ended, but it's a couple of volts peak. And when we get into the circuit diagram, this caused me a lot of problems, but I've managed to figure it out, and we'll go through that. So this unit will just pair to something like one of these type radios without any problems whatsoever. Testing 1 2 1 2, and I've just put that back on. Testing 1 2 3, and if we come down to here, 1 2 1 2 1 2 1 2, we can adjust the deviation level. Yeah, and we can do it electronically. So which is it's pretty neat. There's a lot you can actually do with this. Now before, as we went through, and I'll try it again this time, you see it starts getting washy. It's just because we're too wide. We're now too wide for the receiver. So I think these things are typically about 1.5, 2 kilohertz, deviation level. Okay, so let's take a quick look at the schematic diagram of this multi-mode 2. This is the radio that I had at the side. I mean, we weren't doing anything spectacular with it. We were just hijacking the, it's the mic path audio signal that we were feeding into the Si5351. So if we look down here, let's just highlight this. Zoom in. Now, you've got to remember, this is a very primitive radio. These are pretty old. The design's hot back from the 1970s. I mean, look, I'm not knocking it. It's just, times have changed since these things, were made. But, yeah, the mic audio, when we're going to transmit, passes through, uses the audio amplifier and switches out the speaker basically. And I think you know, it goes through for AM as well. So, but obviously we're only interested in the FM. Now, if we look on the output here, so if I can find my, here it is. See, I think it's pin 10, and yeah, it's pin 10. That's the output of the audio amplifier IC. We've got an AC coupling capacitor, and then we've got this transformer. That's just doing some impedance changing. Yeah, I think later revisions of even this radio went through quite a few revisions. They got rid of the transformer. It sort of harks back, you know, to the 1960s and 70s. But they've, you know, there's better ways of doing it. These, you know, as time went on, I guess. But we've got this marker here, H, and if we come over here, let's go up. We've got this board here, this section here, which is the synthesizer, and what's happening is let's have a look, where is it? Yeah, we're here. So we've got this marker here, H, we've got another AC coupling capacitor, we've got this variable resistor here, which is your deviation level, I imagine, but that's where the signal's coming up, and what I'm doing is intercepting it at this point. So you've got a deviation level on the, you can adjust the deviation level on the radio itself. And I don't know if you noticed, if you saw on the board, there is an actual little potentiometer, and that is for the level as well. Now we'll get further into this when we get into the schematic of the unit. But I'm just explaining that's where I'm picking it up from. Now, they've got a little 1 microfarad capacitor, this coupling capacitor. Now, you know, normally if you're going to modulate FM, you need to put what we call pre-emphasis onto the AF signal, the audio signal. And basically, what it just emphasizes the higher frequencies. That's what they, you know, typically what you would do, because obviously, you know, a lot of FM modulation sort of, you know, is quite strong with the lower frequencies, and you don't really want that. You know, it just swamps you. It just swamps your modulation waveform. Okay, so we're going to stop the video here regarding the new Breakout board. In the next video, we're going to go through the schematics, how it works. Now, I know this isn't for everybody, so I've split it up. And we'll go through the code. And yeah, because I know a lot of people's ears fall off. But these things, we are going to make them available. They will be available. You'll be able to get them from us. I'm trying to get a Chinese outfit to manufacture them, but there's a bit of a problem with the cost of the part. So yeah, we're working on it. It shouldn't be too long. Also, I just want to give an update. A lot of people have been, I sold a lot of these boards. These are the Band Surfer Mark 1s. This is basically you know, it's a VFO, and it will take, you know, a couple of different types of microcontroller. But it's all through-hole components, so they're nice and easy to put together, you know. So people can build them. Now, we are getting some more in. I've made some modifications to this. I'll give you a quick update while I'm here. So what we've added is a facility so that you can use ordinary rotary encoders rather than just being stuck with the Adafruit ones. Now, I've been getting mixed reports about these, so it will still support them, but you'll have another socket on here. You can put a normal rotary encoder on there. That will be for the SP32 only, but yeah, it'll work. And also, this will take, you know, we're actually making the board a little wider and putting an extra set of holes, so it'll take the wider version, ESP32, yeah, because they're cheaper and they've got more memory. So yeah, it'd be, you know, so I thought it'd be a great idea to put that on. I've just about finished the boards. I just want to double check it because if I get a lot made, I just don't want to make then I've got a problem with them. So yeah, we're almost there on that, so that's not far off now. We've also made a Band Surfer Mark II. Now these are appreciably smaller than the other boards. Now there's a lot of features on these. There's, you know, it comes ready built. This one, it'll be fully populated. There's a lot of options on here. Again, this will support an ordinary, you know, rotary encoder, so you can I'll just plug straight in. But there's modules to go, the add-on modules that will go with this, and this the firmware for it. You know, as you saw before, we've got it's all menu driven, so there's no coding required. It can all be done in the menus, and it will support many different types of displays, and these will fit in mobile units. Now, okay, and then George Si5351 is going to showcase one of these actually installed in mobile radio equipment. Now they've just taken quite a long time to develop. There's some super features on here. There's a thing called channel sync. I don't know if you were looking at what that was, but what it does, it tracks, and you can tune with the VFO and it will just change channels automatically. It does all kinds of stuff. It displays SWR and all kinds of carry on. And there's a lot of add-on boards, so you know you can put the wide band it, so you can get all your HF bands with just an add-on board and just obviously switching it on in the menu. Also, there's an up converter board so that you can plug it into something like a simple SDR dongle, one of the cheap dongles, and then you'll get a band scope. So yeah, there's some exciting stuff happening. I know I've been getting a lot of emails. I've been incredibly busy of late, but we are getting there. So if you do, just bear with us. It won't be long now. We're just about there. Okay, so next video we're going to look at the schematic, how this thing works in meticulous detail, and we'll go through how you can code it, because there's a real trick to the code. Okay, so if you watched this, I'll just say thank you. If you like the video, please give us a thumbs up, and we'll see you in the next video.